Hey everybody, I'm going to do a little video here talking about section 7.5 in the OpenStax elementary algebra book called A General Strategy for Factoring Polynomials. So here we go. Alright, so the first thing I'm going to want you to do is go ahead and get to section 7.5 in your book, which is located on page 850 in the book. That's page 858 in the PDF document if that's a help to you. And you're going to want to have out a blank sheet of paper. Go on, pause the video, get a blank sheet of paper. Do that now. Go on, I'm waiting. Pause the video. Okay, hopefully you've got a blank sheet of paper there with you now and something to write with. And on page 7.5, close to the bottom, you're going to see this little chart that says General Strategy for Factoring Polynomials. And the very first thing you see at the top of the page are the letters GCF. Of course, that stands for greatest common factor. And what we mean by that is if you have a polynomial such as this one, that you see, hopefully that you see there's a common factor there of 2x, and you're going to want to factor that out. You're going to want to check every single polynomial that you're asked to factor for that greatest common factor, whether that's a binomial, a trinomial, a four-term polynomial, or otherwise, whether that thing is a sum of squares or a difference of squares or a sum of cubes, or if you're going to need to use the AC method, or you're going to need to factor it like a trinomial with a leading coefficient of 1. None of that matters at this point. Every single polynomial you factor, the first thing you're going to want to do is look for that greatest common factor, okay? Once you've either found that, factored it out, or determined that there's not one, then your next objective is to determine what kind of polynomial you have. If you have a binomial, there are a few options for what to do with those depending on what the actual terms look like. If you have a trinomial, you've got a couple of options there, and you've got usually four-term polynomials. The chart says more than 3. Then you're going to want to factor those things by grouping. So we'll start with the binomials, and we'll start with the all the different kind of shortcut things. At least that's the way I look at them for binomials. So your first one is going to be a difference of squares. So if you have a binomial and your first term is a square and your second term is a square and it's a difference, then that's going to factor into a plus b, a minus b, where the a terms there are the square root of that one and the b terms are the square root of that one. So an example of that would be something like x squared minus 9, and that would factor into x plus 3, x minus 3. Another example of that might be 4x squared minus 16, which would factor into, hey, wait a minute, let's stop. That has a greatest common factor. We better factor it out. GCF is 4, right? And then we can go ahead and factor that difference of squares. There we go. Perfect. So that's one option, difference of squares. Another option would be a sum of squares. And of course we know that those are prime, right? Sums of squares don't factor. So if you end up with something like x squared plus 9, that's going to be prime, so forth and so on. By the way, if you end up with a sum of squares that has a common factor, so I'll just stick with that same example up there, but it's a sum instead of a difference this time. While we can't factor that as a difference of squares, because it's a sum, we can still factor out the common factor of 4. We just can't go any further. So that's not prime. This thing is not prime because of that common factor of 4. Remember, we've talked about that in class. If your if your polynomial has more than 2 factors, it's not prime. So obviously it has the factors of 1 in itself, but this one also has the factors of 4 and x squared plus 4, so it's not prime. We also have sums and differences of cubes, or sums and differences of cubes, or when we have either a cubed plus b cubed, where a and b are the cube roots of those things. Or we have a cubed minus b cubed. And unlike the sums and differences of squares, both of these actually will factor. You can look back into section 7.4 for more information on how they factor, but just so you'll have the shortcut here on that paper that you're writing all this stuff down on, right? That's what you're doing, isn't it? If not, there's a rewind button. You can go back and write down some notes for yourself. Anyway, what was I saying? I'm going to go ahead and write down the shortcut for you. Of course, you're going to want to have looked at this in section 7.4 to know what all this stuff means. So there's your sums and differences of cubes. And basically that's your options for binomial. It's either going to have a greatest common factor or it's not, and then after that it's either going to be a difference of squares, a sum of squares, a difference of cubes, or a sum of cubes, or you're not going to be able to factor it any further. Next on the list we've got trinomials. Trinomials are categorized in 2 ways. I'm just going to kind of split the page in half. Either they have a number in the front of them, so something like that, or they don't. Something like this. If they have a number in the front, you're going to want to do the AC method. And you can find the AC method back in section 7.3. Or if you're not looking in the OpenStax book, you can probably Google the AC method and you'll find that strategy there. Or if it doesn't have a leading coefficient bigger than 1, like the second example over here, then you're just going to want to factor that thing into binomials. Remember, x is in the front. We're looking for factors of 3 that add up to 4. That's 3 and 1. It factors straight away. You don't need the AC method there. Okay? So that's your 2 options for trinomials. Now remember, you've got to check for a common factor before you do anything else. Take a look at this one over here. It has a common factor of 2, right? So your first step in that one is not going to be the AC method. It's going to be to factor out that 2. And then you're going to want to use the AC method on what's in there. Okay? That factor of 2 is going to follow all the way down and be part of the answer. Part of the factored answer. Okay? Keep that in mind. Next up, we've got more than 3 terms, which we've looked at in class is just going to be 4-term polynomials. And of course, anytime you see a 4-term polynomial, you're going to want to factor by grouping. So 4 terms, factor by grouping. And if you need a little bit of assistance on that, you're going to want to look toward the end of section 7.1. You'll see a section there on factor by grouping with some examples. Again, if you're not looking in the book, you can Google factoring by grouping and you'll see some examples of factoring 4-term polynomials. And that's going to be it for this video. Get in the book, try those problems out through the section and the try it problems. Work on factoring completely. Your focus is going to be those notes that you just took. Have those with you as you're working through these. Think about greatest common factor first, no matter what. Okay, that should be your very first thing. Check it. If it doesn't have one, fine. Don't worry about it. But if it does, factor it out first. And when you factor out a GCF, don't forget to include that in your factored solution at the end. Okay? Have a great day, and I will talk to you soon. Bye-bye.